We're starting in Chapter 7. Chapter 7 is going to focus on adding and subtracting fractions and then adding and subtracting mixed numbers. But we're going to go ahead and we're going to start with fractions. And these first two lessons are pretty simple. We're just going to talk about what adding fractions and subtracting fractions looks like, and then we're going to talk about unit fractions and how we can take fractions apart and stick them back together. So let's go ahead and take a look at adding and subtracting fractions. As long as our two fractions have the same denominator, all you have to do is add or subtract the numerators. The denominator does not change. This makes adding and subtracting fractions with the same denominator really easy, because all we have to do is add or subtract that top number called our numerator. So let's look at these examples down here. For the first one, which is an addition problem, we're looking at 1/5 plus 3/5. All we have to do is add our numerators. So we're going to add 1 and 3, and 1 plus 3 gives me 4. And because my denominator is the same, it stays the same. So 1/5 plus 3/5 equals 4/5. Our next problem is a subtraction problem. 5/6 minus 2/6, and we want to know what that difference is, what that is equal to. And so we see that our denominators are the same, so we know we can go ahead and we can subtract. It's important to look to make sure those denominators are the same. If they're not, we have to do a few more steps, but they are. So all we're going to have to do is subtract 5 minus 2, and 5 minus 2 gives us 3, and then our denominator stays the same at 6. And that's it. It's pretty simple when we have the same denominator. All we have to do is add or subtract those numerators. Let's go ahead and take a look at some picture problems. And we need to identify what fractions are they showing us here, and then what are we supposed to do with these fractions. So this first fraction obviously is an addition problem because we see the addition sign between our two pictures. So we're going to need to identify what these pictures look like. The first picture is representing 1/4 as a fraction. And then we have our addition sign. And then a second picture is representing another 1/4. And so we need to add these together. And our picture shows us that 1/4 plus 1/4, and the final picture shows us 2/4. That's it. We added our two fractions together. Let's look at what a different type of problem looks like. In this problem, you see some crossing out. So this is going to be a subtraction problem. How we're going to represent this problem is we're first going to represent the part that's shaded completely. So we need to represent all of this shaded area. If we were to count all of those, we call these unit fractions. They have a 1 in the numerator. So if we count all of our unit fractions, we notice that we have 5 of these 1/8. So we would call this 5/8. And because we're taking them away with that x, we're going to be subtracting. And then we need to subtract the part that's in the circle here. And so 3/8 are what's in our circle. So we're going to subtract 3/8. And we want to find our difference. Our denominator is going to stay the same. So our denominator is 8. That's going to stay the same. And the only thing that we're going to have to do is change our numerator. So we see here in our picture that 5/8 minus 3/8 leaves us here with only 2 unit fractions, or 2/8. And that's it. I want you to go ahead and write the equations and solve these next problems. So here we have an addition problem clearly. What are the two fractions that we're adding, and what is the sum of that addition problem? So for this first one, we have a circle and it's split into 5 equal sections, and 3 of them are shaded in, so we would call this first circle 3/5. And then we're adding one section, or 1/5. And in the final picture, we see that 4 are shaded in out of the total of 5 sections. That's it. That's our problem. Our next one, I want you to write the fractions and solve this equation. All right, so in this equation, we see that our shape is split into 3 equal sections, so that's going to be our denominator, and 2 of those sections are shaded in to start with. Then we're taking one of those sections away. We're taking this triangular section here away, so that would be equivalent to 1/3 being taken away. And then when we figure out what we have left, well, we only have one of these rectangles left that's shaded in, that's not crossed out. So our final answer would be 1/3. 2/3 minus 1/3 equals 1/3. Pretty simple stuff. Let's go ahead and talk about unit fractions. A unit fraction is a fraction with a 1 in the numerator, and a unit fraction is represented as one part of the whole. So in this picture, we have 2 unit fractions that are yellow, and our total rectangle here is separated into 6 pieces, so our denominator would be 6, and we would call each of these pieces 1/6 of our whole, and 1/6 is a unit fraction. So we could represent this. We have 2/6 that are shaded in, and this 2/6 could be represented as 1/6 plus 1/6. These are our 2 unit fractions that we're adding together. We see them in our picture as each of these pieces, 1/6 and 1/6. So that would be representing 2/6 as the sum, which is addition, of a unit fraction. And these are our unit fractions because they have our 1 in the numerator. So let's go ahead and we're going to write these fractions as the sum of unit fractions. The first thing we need to do is we need to identify what that whole is equal to. So in our first picture, what is our whole equal to? And then how many parts are shaded in? Our whole is equal to 8. We have 8 parts that make up our whole, and 3 of those parts are shaded in. So we have 3/8 of our rectangle that's shaded in. And then if we were to represent this as the sum of unit fractions, remember unit fractions are those numbers or those fractions that have a 1 in the numerator, we would need 3 unit fractions to represent 3/8. And notice how we have 3 1/8 here. We're going to do the same thing with our next picture. So I want to know, well, what does this picture represent in terms of a fraction? How much of our picture is shaded? And then what would it look like as the sum of unit fractions? This picture shows us 2/3. 2/3 of our picture is yellow. And then if we were to represent this as the sum of unit fractions, each of these pieces, if I can write that small, is 1/3. So I would have 1/3 plus 1/3, and 1/3 plus 1/3 equals 2/3. Go ahead and do the last one here. What does this picture represent as a whole? And then represent that as the sum of unit fractions. Our picture as a whole represents 3/4. 3 out of 4 of my total pieces that make up my whole are shaded in that bluish color. And then if I were to represent this as unit fractions, I'd have 1/4, 1/4, 1/4. So I would add all of my unit fractions together to represent my whole fraction. And that's it. All right. Our next section, we're going to write fractions as the sum of fractions. Now, we can write these as the sum of unit fractions, but there are also other ways that we can take these fractions apart. The important thing here is that our denominator stays the same. So if I were to represent 5/9, I can think about some addition facts that I know. How can I represent 5 in an addition problem? Well, 5/9 could be equal to maybe something like 3/9 plus 2/9. I could also represent 5/9 as 1/9 plus 4/9, or I could get super crazy and maybe I wanted to add more different pieces. So I could represent 5/9. Maybe I wanted to say, you know what, 5/9 is 1/9 plus 2/9 plus 2/9, and that gives me 5/9. You could also represent 5/9 as the sum of unit fractions. So you would have 5/9, and then you would have all of those unit fractions. And in this case, 5/9 in unit fractions would be 5 1/9 combined together. The next one I want you to do, I want you to represent 4/6 in 2 different ways. What are 2 different sums of fractions? That would be these pieces here that we created. I just want 2 different ways to create 4/6. What are 2 different ways we could add fractions together that would give us 4/6? We could do it quite a few ways. We could have 2/6 plus 2/6. That would be one way to represent 4/6. Maybe we wanted to represent 4/6 as the sum of unit fractions. So we could have 1/6 plus 1/6 plus 1/6 plus 1/6. There are a few different ways that we can represent 4/6 using sum of fractions. Let's take a look at two more problems and then we are pretty much done for the day. Go ahead and represent 6/7 as the sum of fractions. 6/7 could be represented quite a few ways. Here are a few different ways that you could have represented 6/7. We could have had it as the sum of our unit fractions, so we would have had 6 unit fractions of 1/7. We could have also had 3/7 plus 3/7, or 2/7 plus 2/7 plus 2/7, 5/7 plus 1/7. There are quite a few ways. Go ahead and do the same thing for 3/4. And for 3/4, there weren't quite as many ways, but we could have represented this as the sum of unit fractions, so that would be our 1/4 plus 1/4 plus 1/4. Maybe we had 2/4 plus 1/4, or maybe we switched it and used the commutative property and had 1/4 plus 2/4. Any of those ways would work. All right, that's our lesson for today. We talked about writing fractions as the sum of smaller fractions, so adding those smaller pieces together. We also talked about what a unit fraction is. A unit fraction is always represented with a 1 in the numerator. That's super important. And then the number of unit fractions we would have to represent a fraction would depend on the fraction itself. And then we also talked about adding and subtracting fractions, making sure that we add and subtract fractions only when they have the same denominator. But if they do have the same denominator, our denominator does not change. The only thing we do is add or subtract that numerator. See you tomorrow.